A more recent development in the economic theory of the firm has been in the application of the game theory. This began as a branch of mathematics, but it became apparent that it had wide application in explaining even behavior of firms in an oligopoly. The game we would like to focus for our example is the prisoner's dilemma, which is also sometimes is an example of zero sum game. Now, a zero sum game means that if one player gain, then it will be at the expense of another player, which means that the gain of a player is equal to the loss of another player. And within this, we are looking at what's something called a prisoner's dilemma. So let's understand prisoner's dilemma in a general sense, and then we will use this game for the theory of firm. Let's say we have two prisoners or two robbers, Adam and Ben, and they have been detained in separate parts of the prison with no way to communicate with one another. The chief of police meets with each in turn and speaks to them in the same way. And this is what he says to them: I have sufficient evidence to send both of you to prison for 3 years if neither of you confesses. However, if you alone are prepared to confess to the crime, you will receive a light sentence of 1 year, and your partner will receive a prison sentence of 10 years. If both of you confess, you will both receive a sentence of 5 years. Now, knowing that these guys are not talking to each other because they are separated, and the fact that they need to now evaluate their options, what should Ben and Adam do? Let's see this in terms of a table, because this will be best analyzed by looking at the options that are available. So according to the police officer, if they both decide to not confess, he has enough evidence to give them a punishment of 3 years. So I can say both of these guys will get 3 years, 3 years punishment. So this is for Adam, while this is for Ben. On the other hand, if Adam decides to confess and Ben says he hasn't committed the crime or does not confess, then Adam will get a punishment of 1 year, while Ben will get a punishment of 10 years. Why is that so? Well, because Adam is admitting to the crime and Ben is not. On the other hand, if Ben decides to confess and Adam says, I have not committed the crime, then Ben will get a punishment of 1 year and Adam will get a punishment for 10 years. While if they both decide to confess, then of course none of these guys will get any advantage, and therefore both of these guys will get punishment of 5 years. Now, with these sort of options, we call them the payoffs for these guys, these two individuals. So what is the best strategy for them? Let's look at Adam's perspective. So Adam is going to be like, if I think that Ben will not confess, what is good for me, to not confess or to confess? Well, if Ben, he thinks, is not confessing, and if he doesn't confess, then he gets 3 years of punishment. But if he decide to confess, he will get 1 year of punishment. So he'll be like, if I am confident that Ben will not confess, it's better for me to confess, because 1 is better than 3, because I don't want to have 3 years of punishment. I will rather be happy with 1 year of punishment. However, if he thinks Ben is going to confess, then if he doesn't confess, he'll get 10 years of punishment. But if he does end up confessing, he will have 5 years of punishment, which means that he will end up confessing irrespective of what Ben does, because even if Ben confesses or not confesses, it is in the best interest of Adam to always end up confessing. Now, Ben will also be thinking on the same lines, because the payoffs are completely identical. If Ben is thinking that Adam is not going to confess, then Ben can also not confess and get 3 years of punishment, or confess and get 1 year of punishment. So what is better? Clearly, committing to the crime or confessing is better, because 1 is better than 3. On the other hand, if Ben thinks that Adam is going to confess to the crime, then clearly 10 by not confessing, he will have 10 years of punishment, but by confessing, he'll get 5 years of punishment. Again, he will also end up confessing, because 5 is better than 10. So as you can see that we have 2 ticks here, which means this comes out to be the equilibrium. Now, clearly this is not the best outcome. Why? Because both of them have ended up confessing, and the total punishment is 10 years, which is not a good outcome. The best outcome could be, they could cooperate. If they had cooperated, then they would have a combined punishment of 6 years, and they both would be happy, because 3 is still better than 5. But the fact that they could not trust each other, and the fact that they could not collude with each other, and in the absence of any ability to communicate with one another, this is unlikely. And even if they could communicate with one another, the fact that there is a lack of trust with the way the game is designed, there will always be a sort of advantage to confess, which will make them end up confessing. Now let's use this to our theory of firm. Let's say we are looking at a case of two firms in the market, which will be what we call duopoly, where there are only two firms in the market, and we assume that these firms have equal costs, identical products, and even the market share is sort of equal amongst the two firms. So the initial demand for their good is the same.
Now, let's say they both are considering an option of leaving price unchanged or lowering price. Therefore, each firm has two strategies, either to lower price or leave price unchanged. And if they both cooperate, they will leave price unchanged and make a profit of 10 million each. So these values are the profitability, which is 10 and 10 million each, which is a cooperation kind of a situation where they come together and say, hey, let's not change the price. However, if they get into competition, or if one of them lowers the price and other doesn't, for example, firm A say, I'm going to lower my price, and firm B doesn't do that, then firm A, by lowering the price, will take away the market for firm B, and they'll make a profit of 15 million, while firm B will only make a profit of 5 million, and vice versa. If firm B lowers the price and firm A doesn't leave the price unchanged, then we're looking at a situation where firm B will make a profit of 15 million and firm A will only make a profit of 5 million. Now, the way we'll play this game is, of course, we'll first consider what will firm do, thinking of how firm A will react to it. So if firm B is thinking that firm A will lower price, they can also lower price and get a profit of 8 million, or they can leave price unchanged and get a profit of 5 million. So clearly, what is better for firm B is that if firm A, according to them, is thinking of lowering price, they should also lower the price, because 8 is better than 5. But if firm B is thinking that firm A is going to leave price unchanged, then the best strategy for them will be that if they leave price unchanged, then they should also think about not doing that, because if they lower the price, they get profit of 15 million, but if they leave the price unchanged, they get a profit of 10 million. So if firm B thinks firm A is going to leave price unchanged, again, they should lower the price, because firm B will make 15 versus 10, which means that firm B, irrespective of what firm A does, lower price or leave price unchanged, will always try to lower the price, because lowering price will give them a better sort of profit than leaving price unchanged. Now let's look at firm A's perspective. Firm A is going to first think about what will firm B do. If firm A thinks that firm B is going to lower price, then this means firm A will think about, should I also lower my price or should I leave it unchanged? Clearly, you can see the firm A is better off lowering the price, because 8 is better than 5. Lastly, if we look at the case of firm A thinking that the firm B will leave price unchanged. If firm A thinks firm B will leave price unchanged, they have two options. Either they lower price and get 15, or leave price unchanged and get a profit of 10. Clearly 15 is better than 10, so I'll put a tick here. So therefore, you can see firm A is always lowering price, which means irrespective of what firm B does, firm A is always lowering the price, which means both firms are now ending up with a scenario of lowering price, which means lowering price becomes our equilibrium. Another way to look at this is through maxi-min and maxi-max strategy. A maxi-min strategy in game theory is a conservative strategy chosen by a player which provides the best of the worst possible outcomes of a decision. So if you look at this, if firm B is to lower the price, and if firm A will leave price unchanged, then firm B will get a profit of 15 million. However, if firm B is to respond by lowering the price, then the worst that can happen to firm B, given firm B is lowering price, is that they get 8 million. So for them, the conservative strategy will always be to lower price, because they will get 8 million versus 5 million if they leave the price unchanged. An alternative approach that B might take is a more optimistic, if riskier strategy known as maxi-max strategy. In game theory, a strategy chosen by a player which provides the best of the best possible outcomes of a decision is called maxi-max. So, if we assume that firm B will respond to any move by firm A which leads to the most sort of advantageous outcome in terms of profit for firm B will be what we call a maxi-max strategy. In this case, B would assume that A will always leave the price unchanged and will not lower the price, and that will mean if that is what the scenario firm B is thinking, then firm B will always end up thinking about lowering their price, because for them, if they believe firm A is to leave the price unchanged, then 15 is better than 10. So both the maxi-max and the maxi-min strategy are giving the same result, which is that firm B will lower the price, and similarly firm A will also lower the price. So we can say this, that the players adopt the maxi-max or maxi-min strategy will then end up reducing or lowering the price, which means this becomes our dominant strategy. A dominant strategy in a game theory is simply a strategy which leads to the best outcome for a player, irrespective of the strategy adopted by the other player.
Hence, the dominant strategy for each firm will be, in this case, to lower the price, because this is the best outcome for a player, irrespective of the strategy that the other player adopts. Now, we come to the last idea, which is called Nash Equilibrium. So, what is Nash Equilibrium? In game theory, a solution in a non-cooperative situation in which each firm's best strategy is to maintain its present behavior given the present behavior of the other firm in the market is called Nash equilibrium. Now, what do we mean by this? We simply mean to say is this, that if each firm wants to maintain the current behavior, which in our case was reducing price given the present behavior of the other firm, as we saw, then clearly this will be what we call a Nash equilibrium, because now the firms are not willing to change its strategy unless the other does. It is important to note that while this final position represents equilibrium by acting completely independently in a non-cooperative fashion, the firms have failed to achieve the best possible outcome. The best possible outcome was a situation in which both of these firms could have cooperated. Now, if you look at this, the 10 and 10 million profit is the highest, which means they have ended up choosing a worse outcome for them, which is 8 and 8 million. Hence, this type of game where the non-cooperative equilibrium makes both players worse off is called the prisoner's dilemma. If these firms could collude and leave price unchanged, then clearly that will be the outcome which will be beneficial for both firms. But because they lack trust with each other, and the fact that they cannot communicate means they will end up choosing lowering price, which is again an outcome that will be non-optimal. In this video, we've only looked at two-player single move, which is non-repetitive and zero-sum games, but it is clear even from this that game theory provides a very useful framework for analyzing the behavior of firms in an oligopoly. In the real world, however, games are far more complicated. Not only do most oligopolistic markets comprise of more than two firms, but the firms within the market have more than one single strategy available to them to influence their profits.